Hello! I'm Alex, the area cheerleader, here to talk to you about areas of parallelograms and triangles.
First vocabulary term is a base. That's any side of a polygon. So typically, you're only used to the base being the side on the bottom of the figure, but technically any side of the polygon could be a base of the polygon. Now, an altitude is a line segment that is drawn from a vertex to the opposite base and is perpendicular to that base. Now, it was important to note that any side of your polygon could be considered a base because we're going to be dealing with some area formulas that have base and height in them. So the base is just going to be whatever side of your polygon is perpendicular to your height, aka your altitude. And that brings us right into our third vocabulary term, which is height. That would just be the length of the altitude. So as you've seen in geometry, we often use height and altitude interchangeably. Just know that an altitude specifically has to come from a vertex and be perpendicular to the opposite side. Now, the perimeter would just be the sum of the lengths of the sides of a polygon. So if I were to add up all of the side lengths of a given polygon, that's your perimeter. So the perimeter of parallelogram ABCD here is 5 centimeters plus 3 centimeters plus 5 centimeters plus 3 centimeters, which is 16 centimeters. Now let's talk about the area of a rectangle. So the area of a rectangle is the product of its base times height, aka area is equal to base times height. So anytime you have a rectangle and you want to determine the area of that rectangle, it's just equal to the length of one of its bases times the height. I also want you to note that, again, the base doesn't necessarily have to be the side length on the bottom of your figure. It could be on the left or the right or on the top. The height is always going to be the perpendicular distance between those bases in a rectangle. Now let's talk about the area of a parallelogram. So the area of a parallelogram is the product of a base and corresponding height. So just like the area of a rectangle, the area of a parallelogram is also equal to base times height. Again, your base doesn't necessarily have to be just the side on the bottom of your figure. It could be on the left or the right. Also, your height could technically be outside of your figure, like over here. If you're coming from this vertex up here, your height is going to be perpendicular to the continuation of this side length. So again, area of a rectangle formula is area is equal to base times height. Area of a parallelogram formula, still area is equal to base times height. Now you may be thinking, how in the world can the area of a parallelogram formula be the same as the area of a rectangle formula? Well, in a parallelogram, what happens is if I were to drop an altitude from this vertex right here, it actually creates this little right triangle right here. And the funny thing about this little right triangle is that if I were to take this and slide it over to the other side of the parallelogram, it fits perfectly over here and creates this rectangle, thereby allowing us to use the exact same area formula as we did for a rectangle. That's why the area of a parallelogram is also equal to base times height. Now let's talk about the area of a triangle. So the area of a triangle is 1/2 the product of its base and the corresponding height. Now a couple things I want you to note here. First is that your height is going to be the length of the altitude that comes from a vertex and is perpendicular to the opposite side. Your base is going to be the side that the altitude or your height is perpendicular to. The second thing I want you to note is that sometimes the height of your triangle may be located outside of your triangle. Now the reason is because when you draw an altitude, it comes from a vertex and is perpendicular to the opposite side. But there's no way for you to draw an altitude that comes from this vertex and is perpendicular to the opposite side within the triangle. It must be perpendicular to the continuation of that side outside of the triangle. Just know that this is your height and your base is only this length right here. It's not part of the continuation at all. The third thing I want you to know is that in a right triangle, the base and the height are going to be the two legs that are perpendicular to each other. So in this case, your height would be the length of this leg, your base would be the length of this leg. Technically, you could switch these two things and you would still get the correct area for this triangle. Now let's talk about why the area of a triangle formula is 1/2 base times height. Below we have this rectangle, and we know the area of a rectangle formula is area is equal to base times height. So what we're going to do in this rectangle is we're going to draw a diagonal connecting one vertex to the opposite vertex. Now what happens when we do that is we have created two right triangles here. And because we have two right triangles, we know that each of these triangles contain half of the area of this rectangle. Meaning, if I wanted to find the area of just one of these right triangles, what I would do is I would take the area of this rectangle and multiply it by 1/2 or divide it by 2. So the area of one of the triangles then would be 1/2 base times height. That's where the area of a triangle formula comes from. And this process would still hold up even if it wasn't a right triangle, because you would just do the same thing but with a parallelogram. And we know the area of a parallelogram formula is still base times height, meaning the area of one of the triangles when you cut that parallelogram in half will still be 1/2 base times height.
Example time.
Now example 1 says find the perimeter and area of the given rectangle. So the first thing we're going to do is find the perimeter. Now remember, this is a rectangle, meaning it's also a parallelogram. And we know in a parallelogram, opposite sides must be congruent. So if this side is 7 inches, this side must also be 7 inches. If this side is 3 inches, this side must also be 3 inches. So now all you have to do to find the perimeter of this rectangle, or any polygon for that matter, is just add up all of these side lengths. When we do that, we end up getting a perimeter of 20 inches. Next, we want to find the area of this given rectangle. And we know the area formula for a rectangle now is area is equal to base times height. So in this figure, remember, you could pick 3 inches as your base and 7 inches as your height. Or you could pick 7 inches as your base and 3 inches as your height. Either way, you'll end up getting that your area for this rectangle is 21 inches squared, or 21 square inches.
Time for a U-try!
Okay, doing the same thing here. So the first thing we want to do is find the perimeter of this rectangle. And remember, a rectangle is a parallelogram, meaning both pairs of opposite sides are congruent. So if the measure of this side length is 9.1 yards, so is the measure of this side length opposite it. If the measure of this side length is 1.3 yards, so is the measure of this side length opposite it. Now to find the perimeter, all we have to do is add up all the measures of our given side lengths, and we end up getting that the perimeter of this rectangle is 20.8 yards. Next, to find the area of this rectangle, we have to multiply base times height. Now in this figure, because it's a rectangle, you could say 9.1 yards is your base and 1.3 yards is your height, or you could say 1.3 yards is your base and 9.1 yards is your height. Either way, when you multiply those together, you end up getting that this rectangle has an area of 11.83 yards squared, or square yards. Now example 2 says find the perimeter of the given rectangle. So we have a rectangle down here where we're given one side length and the area of that rectangle. So in order to find the perimeter, we clearly need to add up all of the side lengths, and that will give us our perimeter. But we are only given one side length. So our first step here should be to figure out what these missing side lengths are. So how do we do that? Well, this is a rectangle, meaning it's also a parallelogram. So both pairs of opposite sides are going to be congruent. So if this side length over here is 9 feet, that means the side length opposite that would also be 9 feet. Now we don't know either of these opposite side lengths, so we need to give them a variable. We'll call them x. Now to find our perimeter, all we have to do is just figure out what these x's are. So how do we set up an equation in order to solve for x? Well, we're given the area of this rectangle. We know that the area of a rectangle formula is area is equal to base times height. So what we can do is we can take the area of this rectangle, which is 54 feet squared, or square feet, plug it in for our a. For our base and height, we can plug in 9 feet and x feet. Doesn't matter which one you plug in for which. I plugged in x feet for our base and 9 feet for our height. We then can solve for x by dividing both sides by 9 feet, and we end up getting x is equal to 6 feet, meaning these two side lengths of our rectangle are 6 feet. So in order to find the perimeter, all we have to do is add up the length of each side in our rectangle, and we get that the perimeter of this rectangle is 30 feet.
You try!
Okay, doing the same thing. We want to find the perimeter of this given rectangle, and we're only given one side length and the area. So clearly, what we need to do in order to find the perimeter of this rectangle is find the length of these three missing sides. So how do we do that? Well, we know that this is a rectangle, meaning it's also a parallelogram. So both pairs of opposite sides are going to be congruent. So if this side length is 8.4 feet, that means the side length opposite that is also 8.4 feet. These two side lengths, we don't know either of them. So what we're going to do is we're going to give them a variable. We're going to call them x feet. Now all we have to do is find x in order to find this perimeter. So how do we find x? We need to set up an equation in order to solve for x. And we are given the area of this rectangle. So we're going to use the area of a rectangle formula in order to solve for our missing side length. We're going to take 105 feet squared, or square feet, plug that in for our a. And we can plug in 8.4 feet and x feet for our base or our height. It doesn't matter which one you plug in for which. I then solve for x by dividing both sides by 8.4 feet, and I get that x is equal to 12.5 feet. So that would be the length of each of these pair of opposite sides. So all I have to do now to find the perimeter is just add up each of these side lengths, and I get that my perimeter of this rectangle is 41.8 feet. Now example 3 says find the perimeter and area of the given parallelogram. So the first thing we're going to do is find the perimeter of this parallelogram. And we know in a parallelogram, both pairs of opposite sides are congruent. So if the measure of this side length is 15 inches, that means the side length opposite that is also 15 inches. If this side length is 12 inches, that means the side length opposite that is also 12 inches. So to find the perimeter, I just add up all of these side lengths, and I get that the perimeter of this parallelogram is 54 inches. Next, we need to find the area of this parallelogram. And the area of a parallelogram formula is area is equal to to base times height, just like a rectangle. So, like we said before, any of these sides could technically be a base, but our base must be perpendicular to our altitude. And we're only given one altitude here, this 10 inches. So we're going to take 10 inches, plug it in for our height, and the 15 inches right here that is perpendicular to this altitude, to our height, is going to be our base. That's what we plug in there. We then multiply these together. We get the area of this parallelogram is 150 inches squared, or square inches.
Here we go, you try, here we go.
Okay, doing the same thing. So first we want to find the perimeter of this parallelogram. And we know in a parallelogram, both pairs of opposite sides must be congruent. So if this side length is 11.8 centimeters, that means the side length opposite that must also be 11.8 centimeters. If this side length is 3.1 yards, that means the side length opposite that must also be 3.1 yards. So to find the perimeter, we just add up all of those side lengths, and we end up getting that the perimeter of this parallelogram is 29.8 centimeters. Next, we need to find the area of this parallelogram. And we know the area of a parallelogram formula is area is equal to base times height, just like a rectangle. Now, like we said before, any of these sides could technically be your base, but since we're only given one altitude, that means your base must be perpendicular to that altitude. So this 11.8 centimeters, that's the side length that's perpendicular to this altitude, so that is going to be your base. That's what we're going to plug in for B. Your 2.7 centimeters, that's the length of your altitude, that goes in for your height. You then multiply those together, and you get that the area of this parallelogram is 31.86 centimeters squared, or square centimeters. Now, example 4 says the parallelogram below has an area of 278.46 millimeters squared, or square millimeters. Find the perimeter of the given parallelogram. Now, when finding the perimeter, you just need to add up all of these side lengths. But here we have 3 missing side lengths. So our first step should be to find our 3 missing side lengths. So we know that this is a parallelogram, meaning both pairs of opposite sides are congruent. So if this side length is 23.5 millimeters, that means the side length opposite that must also be 23.5 millimeters. If we don't know either of these opposite side lengths, we need to give them a variable. So we're going to call this one x, which means this one is also x. So because we are trying to find the perimeter, we clearly need to figure out what x is. So we need to set up an equation in order to solve for x. Well, in this question, it gives us the area of our parallelogram. So what we can do is we can set up the area of a parallelogram formula, which is area is equal to base times height. We could plug in this area for the area down here. Now, like we said before, any of these sides could technically be your base, but since we're only given one altitude, that means your base must be perpendicular to that altitude. So this x, we can plug that in for our base, and then our height, that would be the length of the altitude that's perpendicular to that base, which would be this 21 millimeters. So we can plug that in for our height. Now all we have to do is solve for x. So we divide both sides by 22.1, and we end up getting that x is actually equal to 12.6 millimeters. So when we replace that in our figure up here, we can now calculate the perimeter of this parallelogram by adding up all of these side lengths and getting the perimeter of our parallelogram is 72.2 millimeters.
Michael Scott said, Wayne Gretzky said, you miss 100% of the shots you don't take. You try it.
Okay, this time it says the parallelogram below has a perimeter of 28.82 centimeters. Find the area of the given parallelogram. So in order to find the area of a parallelogram, we need base times height. Well, the height would be the length of this altitude right here, and the base would be the side that is perpendicular to that. So really, all we have to do is figure out what this side length is, and we can answer this question. So how do we figure out what this side length is? Well, we're going to have to use the perimeter that we're given. And we know the perimeter of a parallelogram is just all of these side lengths added together. Well, we're only given one side length, so we need to find these missing side lengths. Well, in a parallelogram, you know that both pairs of opposite sides are congruent. So if this side length is 9.3 centimeters, then the side length opposite that would also be 9.3 centimeters. If we don't know either of these opposite side lengths, then we're going to give them a variable. We're going to call them x. Now what we can do is set up a perimeter equation where the perimeter of this parallelogram is equal to all of these side lengths added together. Now, plug in what I know. I know the perimeter of this parallelogram is 28.82 centimeters, so that's going to go in here. I know two of these side lengths are 9.3 centimeters, and the other two side lengths are x. So I'm going to combine like terms. 9.3 plus 9.3 is going to be 18.6, and x plus x is going to give you 2x. I then subtract 18.6 from both sides, divide both sides by 2. I get x is equal to 5.11 centimeters. I plug that in for each of those side lengths, and now what I can do is find the area of this parallelogram by using the formula area is equal to base times height. Remember, the base has to be perpendicular to your height. In this case, our base is going to be this 5.11 centimeters. Our height is going to be the length of this altitude, which is 7.4 centimeters. We plug those in, we multiply, and we get the area of this parallelogram is 37.814 centimeters squared, or square centimeters. Now example 5 says find the perimeter and area of the parallelograms below. Round answer to the nearest tenth if necessary. So the first thing we want to do is find the perimeter. And in order to find the perimeter, all you have to do is just add up all of the side lengths. Because this is a parallelogram, we know that both pairs of opposite sides have to be congruent. So if this side length right here is 10 rad 2 inches, that means the side length opposite that is also 10 rad 2 inches. If this side length is 9 inches, that means the side length opposite that is also 9 inches. So in order to find the perimeter, all I have to do is just add up all of those 4 side lengths, and that should give me the perimeter. Now, here, when we're combining like terms, we're going to take 9 inches, add that to the 9 inches, we get 18 inches. 10 rad 2 inches plus 10 rad 2 inches is going to give you 20 rad 2 inches. Now, because this question says round your answer to the nearest tenth if necessary, you technically could just plug all of this in your calculator and get that the perimeter is approximately equal to 46.3 inches. Now that we found the perimeter, the next thing we need to do is find the area. So how do we find the area of a parallelogram? Well, the area of a parallelogram formula is area is equal to base times height. Now remember, technically any of these sides could be the base, but because we only have one altitude right here, we need to make sure that our base is perpendicular to that altitude. So this segment right here, this 9 inches, that is going to be our base. So that's what we're going to plug in for B. For our height, we need to figure out what is the length of this altitude. Well, how do we do that? It's not given. Well, what we do have here is this right triangle. And this right triangle has one acute angle being 45 degrees, meaning the other acute angle measure must also be 45 degrees, making this a 45, 45, 90 degree triangle. And we know in a 45, 45, 90 degree triangle, the lengths of the legs are going to be congruent to each other, and the length of the hypotenuse, the side opposite our 90 degree angle, is going to be rad 2 times the length of a leg. So if our hypotenuse is 10 rad 2, all we have to do is divide that by rad 2, and we get that each of our legs here would be 10 inches, meaning that the length of our altitude, our height in this case, would be 10 inches. So we can plug that in for our height here, and remember 9 inches went in for our base. We multiply those together, we get the area of this parallelogram is 90 inches squared, or 90 square inches. Part B, we again have a parallelogram and we want to find the perimeter and area. So we're going to start by finding the perimeter of this parallelogram. And we know in a parallelogram, both pairs of opposite sides are going to be congruent to each other. So if this side length is 18.2 centimeters, that means the side length opposite that is also going to be 18.2 centimeters. If this side length is 8 centimeters, that means the side length opposite that is also going to be 8 centimeters. So in order to find the perimeter, I just add up all of these side lengths and I end up getting that the perimeter of this parallelogram is 52.4 centimeters. Now let's find the area. The area of a parallelogram formula is area is equal to base times height. Now remember, technically any side length could be our base here, but our base has to be perpendicular to our height. And if this is our height, our base has to be the side perpendicular to that. So that would be this 18.2 centimeters. So that's going to go in for our B. But what about our height? It's not given. Well, what we are given is this 30-degree angle right here. So what I can do is take this height actually and slide it up to make it an altitude coming from this vertex. The reason I do that is because now I have created this little right triangle here. And in this right triangle, I have one of the acute angle measures being 30 degrees. That means the other acute angle is going to be 60 degrees, making this a 30, 60, 90 degree triangle. Now, how does that help us? Because we know in a 30, 60, 90 degree triangle, everything is based on the short leg, the side opposite our 30 degree angle, which would be our height in this case. So in a 30, 60, 90, if I multiply the short leg by 2, I get the length of the hypotenuse, which in this case would be the side opposite our 90 degree angle, this 8 centimeters. Meaning, in order to go the other way, in order to get the length of our shorter leg, I would divide our hypotenuse by 2, and that would give me the length of our shorter leg. So what is 8 centimeters divided by 2? That would be 4 centimeters. So that is the length of our shorter leg, which is the height in this case. So I can take that 4 centimeters, plug it in for our height, and now I just multiply 18.2 times 4. I get our area of this parallelogram is 72.8 centimeters squared, or square centimeters.
Dribble it, pass it, you should try it.
Okay, doing the same thing here. So first, what I want to do is find the perimeter of this parallelogram. And in order to find the perimeter of the parallelogram, I need to add up all of the side lengths. Well, in a parallelogram, we know that both pairs of opposite sides are congruent. So if this side length is 14 inches, that means the side length opposite that would also be 14 inches. If this side length is 9 inches, that means the side length opposite that would be 9 inches. So the perimeter of this parallelogram would just be 14 plus 9 plus 14 plus 9, which gives you 46 inches. That is the perimeter of this parallelogram. Next, we need to find the area of this parallelogram. parallelogram. And remember, the area of a parallelogram formula is just area is equal to base times height. So in this parallelogram, any of these sides could technically be our base, but our base has to be perpendicular to our height, and our height is the length of our altitude. So our altitude in this case, we're going to use this segment right here, which means the side that is perpendicular to that would be this side length right here, this 9 inches. So that's going to be our base. The question is, what is our height? What's the length of this altitude? Well, as you can see, we have this little right triangle over here where one of the acute angles is 45 degrees, meaning the other acute angle is also going to be 45 degrees, making this a 45, 45, 90 degree triangle. And in a 45, 45, 90 degree triangle, we know the lengths of the legs are going to be congruent, and the length of the hypotenuse is going to be rad 2 times one of the legs. So all we have to do to figure out one of the legs is just take our hypotenuse and divide that by rad 2. So what is 14 divided by rad 2? Well, you multiply the numerator and denominator by rad 2, and you get 14 rad 2 over 2, which simplifies to 7 rad 2. That's going to be the length of our altitude, which is our height. So that is going to be what we plug in for h over here. And we look, how does this question want our answer? It wants it in simplest radical form. So we're just going to take the 9, multiply it to the 7, and then tack on that rad 2, and say that our area of this parallelogram is 63 rad 2 inches squared, or square inches. Part B, doing the same thing. You want to first find the perimeter of this parallelogram. To find the perimeter of a parallelogram, you just got to add up all the side lengths. So what are these two missing side lengths? Well, remember, in a parallelogram, both pairs of opposite sides are congruent. So if this side length is 6 centimeters, that means the side length opposite that is also 6 centimeters. If this side length is 10 centimeters, that means the side length opposite that is also 10 centimeters. So to find the perimeter, we just add up all of those side lengths. We get the perimeter of this parallelogram is 32 centimeters. Next, we need to find the area of this parallelogram. And the area of a parallelogram formula is area is equal to base times height. Now, if you recall, technically any of these sides could be your base, but your base has to be perpendicular to your height. So what I'm going to do is I'm going to draw an altitude coming from one of these vertices that is perpendicular to one of the sides. Now, because I'm given this little 60-degree angle right here, I know that I need to use that. So I'm going to draw an altitude coming from this vertex that's perpendicular to this side, meaning this 10 centimeters is going to be our base because it's perpendicular to our height. But what is our height? Well, as you can see, I drew this altitude so that it creates this little right triangle here, where one of our acute angle measures is 60 degrees, making the other acute angle measure be 30 degrees. Now look, we have created a 30-69 degree triangle, and we can use what we know about a 30-69 degree triangle in order to find our height here. In a 30-69 degree triangle, everything is based on the short leg, the side opposite our 30 degree angle. The short leg times 2 gives you the hypotenuse, meaning the hypotenuse divided by 2 gives you the length of the short leg. Now, we can use that to find the length of our longer leg, the side opposite our 60 degree angle. The side opposite our 60 degree angle, the longer leg, is equal to rad 3 times the length of our shorter leg. So the height of this parallelogram is going to be 3 rad 3 centimeters. The base, we said, is the side perpendicular to our height, which is this 10 centimeters. We multiply these together. Since it wants it in simplest radical form, we just multiply the 10 times the 3 out front. We get 30 rad 3 centimeters squared, or square centimeters. Now, example 6 says, given the parallelogram below, find h, round answer to the nearest hundredth. So, how do we find h in this parallelogram? Well, I need to set up an equation in order to solve for h, our height here. Well, what equation involves the height of a parallelogram? Well, that would be area is equal to base times height. So all I have to do is find the area of this parallelogram, then find the length of the base that is perpendicular to this height, and then I could solve for the height. Well, is there any way I can find the base right now? Yeah, because this is a parallelogram, I know that both pairs of opposite sides are congruent to each other. Sweet, so I have my base. The only thing I need now is the area of this parallelogram. So how do I find the area of a parallelogram? Well, that's area is equal to base times height. Well, we just said I have my base, but I don't have my height. Well, if you look, I am given another base and the height that corresponds with that, the height that is perpendicular to that. So I could use this base and this height to find the area of this parallelogram. If I multiply those together, I get that the area of this parallelogram is 269.5 meters squared, or square meters. Now what I can do is set up another area formula where I have area is equal to base times height, this time using this base and this height and plugging in the area that I just found, because the area should be the same either way. Now all I have to do is solve for h by dividing both sides by 15.2 meters, and I get that our height is approximately equal to 17.73 inches. Now, example 7 says find the perimeter and area of the triangle. So here we are given a right triangle and we first want to find the perimeter. So in order to find the perimeter, we need to add up all 3 side lengths, but we're missing a side length. So how do we find a missing side length of a right triangle? That would be using the Pythagorean theorem. A squared plus b squared is equal to c squared. The only one it matters which one you plug in for is your c value. That has to be the side length opposite your 90-degree angle. So in this case, that's our unknown side. We'll label that with a c. That means 4 and 12 can go in for a or b. It doesn't matter which is which. We then solve for c by squaring each of these, adding them together, square rooting both sides, and when you square root a variable squared, on the other side you got to put plus or minus. Now because 160 is not a perfect square, we need to break it up into two radicals that multiply together to make rad 160. One of those numbers has to be a perfect square. So that's going to be rad 16 times rad 10. We chose 16 because that's a perfect square. The square root of 16 is 4. Rad 10 is going to stay rad 10. Now because we're dealing with the side length of a right triangle, we're just going to keep the principal root, the positive version. We can't have a negative side length. So C is going to be equal to 4 rad 10 centimeters. So I can plug that in over here, and now I can find the perimeter of this triangle. So the perimeter of a triangle, we just add together all of these three side lengths, and because it says round your answer to the nearest thousandth, you're just going to plug this in your calculator, and you get that the perimeter is approximately equal to 28.649 centimeters. Now I need to find the area of this triangle. So how do I find the area of a triangle? That's 1/2 base times height. The base and the height are going to be perpendicular to each other, meaning in a right triangle, the base and the height are just going to be the legs of your right triangle, and it doesn't matter which one you choose to be the base or the height. You'll get the same answer either way. So I'm going to say the base is going to be this 12 centimeters, the height is going to be this 4 centimeters. We multiply this out and we get that the area of this triangle is equal to 24 centimeters squared, or square centimeters.
It's a you try time. A you try time. Here we go.
So we again want to find the perimeter and area of this triangle. So the first thing we want to do is find the perimeter. Remember, the perimeter is just all these side lengths added together. Now the issue here is we're only given the length of this side length and part of this side length over here. In order to find the perimeter, we need to figure out what the length of this little segment is right here and the length of this side is over here. Well, that's where these little angle measures are going to come in handy. We'll start with the length of this little segment right here. How do we figure out that? Well, in this little right triangle right here, we're given that one of the acute angle measures is 45 degrees, making the other acute angle measure also 45 degrees, making this a 45, 45, 90 degree triangle. And in a 45, 45, 90 degree triangle, the legs are congruent and the hypotenuse, the side opposite your 90 degree angle, is going to be equal to rad 2 times the length of a leg. Meaning that if the hypotenuse is 5 rad 2 inches, if I want to find the length of a leg, I just take the hypotenuse and divide it by rad 2. And I get that the length of each of these legs is 5 inches. Now that I have this, I need to figure out this side length over here. Well, again, I have a right triangle over here. It's a bigger one this time, and we're given one of the acute angle measures is 30 degrees, meaning the other acute angle measure over here must be 60 degrees, making this a 30, 60, 90 degree triangle. And in a 30, 60, 90 degree triangle, we know that everything is based on the short leg, the side opposite your 30 degree angle. The short leg times 2 gives you the hypotenuse, the side opposite your 90 degree angle. So if I multiply this short leg by 2, I end up getting 10 inches, which is going to be the length of my hypotenuse over here. Now I have the length of all three sides in this triangle, so I can add those together. I have 10 inches plus 5 rad 2 inches plus 5 rad 3 inches. I then see that the question wants us to round answers to the nearest tenth if necessary, so all I have to do is just plug all of this in my calculator, and I get that the perimeter of this triangle is approximately equal to 30.7 inches. Now I need to find the area of this triangle. So how do I find the area of a triangle? That's 1/2 base times height. And in this figure, remember, your base can be any of these sides, but it has to be perpendicular to the height. And in this figure, we only have one altitude, which would be this segment right here, meaning our height is going to be 5 inches. So we're going to plug that in here. We then look, which side of our blue triangle here is perpendicular to our height, our altitude? That would be this side over here, meaning that this must be the base of the triangle that I'm going to plug in for my area formula. So 5 rad 3 plus 5 inches is going to go in for my base. 5 inches is going to go in for my height. And then because the question wants us rounding it to the nearest tenth if necessary, we just plug this in our calculator and we get that the area of this triangle is approximately equal to 34.2 inches squared, or square inches. Now part B, we again want to find the perimeter and area of a triangle. So we're going to start with the perimeter. In order to find the perimeter, we just need to add up all of these side lengths. Well, we're missing a side length of our blue triangle. So how do we figure that out? Well, as you can see, the altitude over here is perpendicular to the continuation of this side, making a little right triangle here. And in this right triangle, we have 2 of these side lengths. So we can find the third side length, which is the hypotenuse of this right triangle, which is the third side of our blue triangle over here, by using the Pythagorean theorem. A squared plus b squared is equal to c squared. Remember, it only matters what you plug in for c. That has to be your hypotenuse, the side opposite your 90-degree angle. So that would be our missing side length here. We'll call it c. So now all we have to do is plug in 8 feet and 15 feet for our a or b. It doesn't matter which one you plug in for which. We square each of those, then add them together. Then we square root both sides. Remember, when you square root a variable squared, on the other side you need to put plus or minus. But because we're dealing with side lengths of triangles, we're just going to take the principal root, the positive version. We can't have a negative side length of our triangle. triangle. So we say that C is equal to the square root of 289, which is 17. If we know that this is 17, we can then find the perimeter of this triangle by adding up all of those three side lengths. When we do, we end up getting the perimeter of this blue triangle over here is 43.5 feet. Next, we need to find the area of this triangle, and the area of a triangle formula is 1/2 base times height. Now, in this figure, we said any of the side lengths could technically be the base, but the base needs to be perpendicular to the height that's drawn. And here, the height or altitude that's drawn would be this 8 feet right here. And this altitude is perpendicular to the continuation of this side right here, this 5 feet. So our base of this triangle is going to be 5 feet. The height of this triangle is going to be 8 feet. We plug each of those in there, we simplify, and we end up getting the area of this small blue triangle in here is 20 feet squared, or square feet. Please don't put 20 feet as your base. This is just the continuation of this side length to show that this altitude is perpendicular to this base.